Hi guys, welcome to God Academy. In this lesson, I'll take you through some laws in the number system. In our previous lessons, we've looked at the different categories of numbers in the number system. So we continue in this video. If this is the first time you are visiting this channel, yes, we provide quality tutorials, and in this algebra course, you are solving every problem which you can think about. Stay glued to your seat, follow this video to the end, and subscribe. These are the laws we're going to look at: transitivity law, cancellation law, then the density properties in number systems. Let's start with transitivity law. What is transitivity law and why are we saying it's a law? Basically, and also in the ancient times where mathematics was evolving, so they realized that they needed laws in order for them to simplify mathematical expression. Transitivity simply gives an idea of transition. If I have a number A going into a number B, moving to a number C, is showing transition. A goes to B, goes to C. That is the whole idea. Now, what does transitivity law actually says? It simply says that if I have a number A which is greater than B and B itself greater than a number C, then I can confidently imply that my A is greater than C. Basically, if you have this person standing here, which is taller than this person whom this person is taller, is also taller than another person, then obviously the first person will be taller than what? The last person. That is the whole idea of the transitivity law. And it makes a logical sense in mathematics. Helps us, especially in mathematical induction, where you are to prove for different types of statements. Now let's talk about cancellation law. So what is cancellation law and why cancellation law? So when I come here, so let me write cancellation here. So cancellation law. Now, when you talk about cancellation law, it's just an idea of removing like terms from different sides of equation. So let's see something perfectly here. So now, if I have an equation such that A times C is equal to B times C, what am I seeing here? You realize that we have C here, we have C here. What happens? I can take C away, I can take C away. So that's the idea of the cancellation law. Removing like terms on equal sides of the on the equal side. I'm sorry, on the equal sides of the equal sign. Let me say it that way. So if I have C here, I have C here. Why can't I remove them? Because they're repeating. I just cancel them. Okay. So this cancels this. Then I'll be left with A is equal to B. So this is the idea of the cancellation law. Now, finally, we have this property called the density property. Density property actually is found in rational numbers. Okay. So the density property is found in rational numbers. So density property. What do I mean by density property? Density property in rational numbers simply means that we have what we popularly say that we have Q, that is a set of rational numbers, is dense in R, a set of raw numbers. Okay, Q is dense in R. So what this is trying to say is that if you have any two numbers, say A and B, which are said to be members of Q, okay, then we are going to imply that between A and B, there are infinite many rational numbers between A and B. Now, let's take a typical example. If I have a rational number, let's say 1, a rational number such as 2. These are two rational numbers. 1 is rational number because it can be represented as 1 out of 1. Likewise, 2 can be represented as 2 out of 1. Now, between 1 and 2, we can have infinitely many rational numbers. What's the proof? Within 1 and 2, I can have a number like 1.01. Yes, that is true. 1.011. I can have 1.0000001. I can have 1.99. I can have 1.99999. So before you realize, you can have infinitely many rational numbers between any two rational numbers. And that is a characteristic property of rational numbers, so that within any two, when you take 0.3, 0.5, within these two, there are infinitely many rational numbers. You can have 0.33333 and so on and so forth. And that is the whole idea of Hill being dense in R. Yeah, this is all for you in this lesson. See you in the next lesson.